All right, I'm gonna go a little off the cuff here and go over something that I think is really important to understand if you want to make experiences in AR or video games that are interactive and that have more complex logic than just attaching something in the hierarchy. I wanted to explain what's called the game loop, or maybe we could call it something like a render loop. But essentially, it's kind of how your effect will progress over time. How animations happen, how things change from the beginning of the effect to the end of the effect, and how we can use visual scripting to think in terms of the game loop. Now, every game loop runs on the assumption that something is rendering some number of frames per second. So when you think about a computer monitor, maybe it runs at 60 frames per second. That means it's going through the game loop 60 times every second. On a mobile device with a complex AR effect, you might get some effects running at 60 frames per second, but I think I think of aiming for more like 30 frames per second. That could be important sometimes. But just know that different devices will run at different frame rates. So you'll have the game loop going through a different number of times per second on a low-end Android device compared to the newest iPhone. And this is just because one might have more processing power than the other, and that's just kind of something you have to program for. So considering that something might run more times per second than you can calculate, you kind of have to program around this by using the game loop. This little node that we have here is our update node. This will be called one time every frame. So instead of calling it an update node, you can think of it as a event that happens at the beginning of every frame. This is the first thing that we can think of happening during every frame. And then we do our digital logic based on this, based on other events, and these are all executed within that frame. After all of the visual scripting happens, at that point, then we have our rendering portion of the tool, of the engine happening. So all of this stuff in the visual scripting graph is just putting numbers in different places. It's telling it what color we should use to render this material, what mesh to use, where the mesh should be placed. And then on the rendering side, it sends all of that data to the graphics card or to whatever is rendering the graphics, and it will give it that info and it will render. So if you think about it, every single frame, you have to do all of the data crunching first, and then you render. And you can't really squeeze anything in between. So for instance, when you take a snapshot, you'll probably have to wait for that snapshot to happen until next frame, and then you can take that info, that image, and do something with it. We don't usually do anything with the snapshot. You usually just want to render it to the screen, so that works out fine. But you can consider this update as the main driver of things that you want to happen every frame. Now let's take, for instance, the transform of this circle, this sphere. And we'll think about setting the position. If we plug the update into this node, you can think about it as 30 times every second if we're running at 30 frames per second. This will tell the position of the sphere to stay at 0, 0, 0. Now, if we want it to change over time, then we can use something like this. Let's just do something simple for now. Vector 3. So we'll just make it, plug it into X. So this is going to tell it, during this frame, set the position of my sphere to this value. And as you can see, every frame, it has a different value for time, and so it moves it slightly further to the X direction as it increases. Now, this is kind of how motion works when you have a game loop. If you weren't familiar with the game loop, you might think, well, I want the circle to move to the right, so how can I send a command that says move to the right. But that's the thing, you don't want it to move instantly to the right. You want it to move a little bit right along with the time. A little bit more every frame. So this is one way to do it. Maybe you want it to be a little bit more programmatic, and you don't want it to just go with time, right? You want it to move in a direction. So let's add. So if you do this, you take the position and you want to move it by a little bit every frame. Let's say 0.01. We're going to move it a tiny amount. We're basically going to take the current position, we're going to move it on the X by 0.01, and we're going to do this every frame. Now see how slowly it's moving? Maybe we can do 0.1. And notice how it looks. It's not super smooth, and that might be because we're using a low frame rate in Effect House, because I'm recording the screen, the full screen. But also you have to keep in mind that if we're running at 30 frames per second, it's not going to be the same amount of time between this frame and the next frame and the next frame and the next frame. They're going to be running as fast as they can, crunching numbers as fast as they can, and they might change. If we put a peak node here, we can see the delta time. This value that comes out of update will tell you how much time it's been since the last frame rendered, since the last update call. Notice how it changes every single frame. That's an unavoidable thing that basically happens in every game engine, and one way around it some game engines will do is they'll create a fixed update, where instead of being within this update loop, they'll fire off a separate event that happens on a fixed time slice. So it'll happen every 0.05 seconds. And that's a way to calculate physics more accurately and things like that. But currently, since we don't even have physics, this is the update loop that we're using. And so one thing to keep in mind if it's going to change like this is you need to account for that, because it's going to move 0.1 units for 0.045 seconds, and then the next frame it's going to move the same exact distance for possibly twice that amount of time. So that distance change over the same amount of time means that it's going to move faster and slower. So the one way to get around this is to pull in this delta time, and I guess we have to do a combine so that we can fit it into a vector 3, but really we just want to combine it here. So this this delta time, this will be fine. This delta time, we're just multiplying it by these three so that we can keep it within a vector 3 format, but there's probably a better way. If this was a more formal video, I would get more into that. But then here's the actual thing that we want to move. So if we say x is 0.01 units that we want it to move, and then we multiply by the delta time, then it will shift that so that it's dependent on how much time has passed. We're basically saying if it has moved for 0.08 seconds, then we want it to move further because there's been more time than if it was 0.04. And then with this, you should also divide by your base time. So now that we have it at 0.01 and we know that the time is so small, we probably want to multiply it by some value to bring it back. So we could probably say 0.05, and that will be a relatively slow amount. But looking at this, you can see that it looks much smoother doing this, because the lower frame rate while I'm recording the screen really makes the jumps visible between the timing. So you can see this really smooths it out. And this will be extremely visible when there are things tracking the head and and other things like moving around the screen that are supposed to look smooth. So this is probably one of the most common things that you'll do in terms of the game loop and trying to make smooth motion. Anytime you're moving something every frame, multiply it by that delta time, and then adjust how much you want to move it according to those changes. So I hope that's helpful, and maybe I can give a more thorough example in the future with more details about the game loop. But I hope this at least gets your brain hungry to learn more about the game loop and kind of the ways that you can think about creating an effect in Effect House or other game engines. And hopefully this was informative and not too slow paced. All right, let me know if you watched it and enjoyed. Thanks.